morning, students. Now I'm going to take photodiodes, right? So this photodiode is the one of the optoelectronic devices. So this photodiode is the one of the optoelectronic devices, right? So in last class we discussed LED, right? Now in this class we are going to discuss about photodiodes and solar cell. Okay, students. Okay, see, this is the exact picture of the photodiode. Yes, right? Okay, now, so what is photodiode, right? See, this is the photodiode and this is the one of the type of photodiode, right? And this is also photodiode and this is also photodiode. This is infrared LED, right? Now, what is a photodiode? See, a photodiode is a semiconductor device that convert light into current. So light energy into current. Okay. So light energy into electrical energy. Right? Yes. Now, features of photodiode. See the features. First point. Excellent linearity with respect to incident light. Excellent linearity with respect to incident light. And low noise and wide spectral response and mechanically rugged and compact and lightweight. So it is a compact device and lightweight and long life. So these are the features of photodiode. Right? Now, materials. The more materials commonly used to produce photodiodes, that means for making a photodiodes we used silicon. Yes, in a nanometer range, right? The wavelength in nanometer range, see that silicon between 190 to 1110 and germanium 400 to 1700 and the indium gallium arsenide 800 to 2600 and lead sapphire 100 to 3500. Yes, the spectrum wavelength from range in nanometer, m for nanometer. Okay, students, right? Now, types. The types is nothing but three types, that is PIN photodiode, that is spin photodiode, and PN photodiode is ordinary LED bulbs, and next avalanche photodiode. So these are the three types of photodiode. Okay, now we are going to see the working of photodiode, characteristics and application, right? Okay, now see this. Photodiode is a PN junction diode. Photodiode is a PN junction diode that consumes light energy to electric current. Photodiode is a PN junction diode that consumes light energy to produce electrical current. Sometimes it is also called photodetector. Sometimes it is called as photodetector, right? And a light detector and a photosensor. So sometimes it's called photodetector, a light detector and photosensors, right? And these diodes are particularly designed to work in reverse bias condition. So this is important point. So which condition? Reverse bias condition. It means that the P side of the photodiode is associated with negative terminal of the battery and the N side is connected to positive terminal of the battery. Okay, Again I'm telling, PN junction photodiode is a PN junction diode that consumes light energy to produce photoelectric current. So sometimes it's called as photodetector, light detector, or photosensor. Yes, so light detector is nothing but to detect the light and to produce current. So that is the detector, right? And these diodes are particularly designed to work in reverse bias condition. So only in reverse bias condition. That means P side of the photodiode is associated with negative terminal of the battery and the N side is connected to positive terminal of the battery. Yes, please remember the PN junction diode connected in reverse bias condition. Yes, the same, yes, condition. Yes, the same circuit. Okay, students, right? Okay, next again, this is the extra points. See the first point. A photodiode is one type of light detector and is used to convert the light into current or voltage based on the mode of operation of the diode. Based on the mode of operation of the diode. And it compresses of optical filters. It compresses of optical filters and built-in lenses and also surface areas. Yes, surface areas. And these diodes are having slow response time when the surface area of the photodiode increases. At the same time, photodiodes are alike to a regular semiconductor diodes. So photodiodes are just like a regular semiconductor diodes, that is ordinary semiconductor diodes. Okay, okay students, right? Next, just see that symbol of the photodiode. See, this is the photodiode symbol. Okay, so except this arrow marks ordinary PN junction diode. If arrow marks present like this, that is a photodiode. So this photodiode under forward bias condition, conversion current will flow from the anode to cathode and following the arrow marks in the diode symbol. So photocurrent flows in the reverse direction. Photocurrent flows in the reverse direction, right? Okay, okay students, right? Okay, shall we go to the next slide? Yes, see, this is the photodiode, 3 terminals. So this is that near this one cathode, near this one cathode, right? And opposite to these two are anode, right? Okay, right? Photodiode exact. So this is the top of the photodiode. When the light is incident on this one, it will convert into current. Okay, right? Except that types of photodiode. So we already discussed type of photodiode, 3 types. Except the types, this is that another types. Okay, see that the types of photodiode can be classified based on its construction and the functions. So based on its construction and functions. What is the first one? PN photodiode and Schottky photodiode and a PIN photodiode, avalanche photodiode. So we discussed these three things: PN, PIN, and avalanche. And this is the exceptional one, Schottky photodiode. Okay, okay, students, right? Okay, now material to make a photodiode. Listen carefully. The required material to make a photodiode and the range of electromagnetic spectrum wavelength range include the following. So electromagnetic spectrum range is very important to make a photodiode, right? Yes. For silicon material, the electromagnetic spectrum wavelength range will be 192,100 nanometer. For germanium material, the electromagnetic spectrum wavelength range from 400 to 1700 nanometer. For indium gallium arsenide material, the electromagnetic spectrum wavelength range will be 800 to 2600 nanometer. Okay, so I'm highlighting silicon, germanium and indium gallium arsenide. So these are the three materials to make a which one? Photodiode. Okay. Okay, students. Yes, right. Next, working of photodiode. Working of photodiode. See the one, when a photon of ample energy of strike the diode. When a photon of ample energy strike the diode, that means the photon of amount of energy strike the diode, it makes a couple of electron hole. So when a photon incident on the diode, it makes a couple of electron holes, and this mechanism is also called as a inner photoelectric effect. Photoelectric effect is nothing but when light energy incident on the surface of the material, it emits electron. So photon incident on the material, so it emits electrons. That is called as what? Photoelectron. So that effect is nothing but photoelectric effect. So this mechanism is also called as inner photoelectric effect. If the absorption arises in the depletion region junction, the absorption rises in the depletion region junction. So depletion region, what will happen? Absorption will be takes place, right? Which absorption? That electron holes absorption. And then the carriers are removed from the junction by the inbuilt electric field of the depletion region, by that inbuilt of the depletion region. Okay, it carry removed from the junction. Okay, which removed? Electron holes will be removed. Okay, right. Continuation. The holes in the region move towards the anode. The holes in the region moves towards the anode, and electrons move towards cathode, and a photocurrent will be generated. I said no, electron hole pairs are created, no. So that ones are holes are move towards anode and the electron move towards cathode. Due to that, a photocurrent will be generated. And now the entire current through the diode is the sum of the absence of light and the photocurrent. So the entire amount of the current in the diode is the sum of the absence of light and the photocurrent. So the absent current must be reduced to maximize the sensitivity of the device. So the absent current must be reduced to maximize the sensitivity of the device, right? Okay, okay students, right. Now come to that function. See, this arrow marks is the incident photon, that is light, and light incident on the diode. So light consists of photons, no, that's why incident photons. Now this is what? PN junction diode. So this is the P type and this is the N type. So N type is connected to positive and P type is connected to negative. See, this is reverse bias condition, no? Yes, in this one the depletion region is very high, right? So what happens? See that the electrons are moved towards positive terminal of the battery and the holes are moved towards the negative terminal of the battery. Yes, So inside that, few holes are cross the junction, refining holes takes place. So what will happen? Inner photo electric current will be generated. Inner photo electric current will be generated. Okay, students, right? So in absence of light, what will happen? There is no photoelectric current inside the diode. There is no photoelectric current inside the diode. Okay, students, right? Yes. Next, characteristics. VA characteristics, that is voltage current characteristics of diode. See the first point. A photodiode continually operates in a reverse bias mode. Which mode? Reversed biased mode. And second point, the photo current is nearly independent of reverse bias voltage which is applied. So nearly independent of reverse bias voltage. It is independent of reverse bias voltage, right? And next, the photo current is nearly independent of reverse bias voltage, except that for zero luminescence. For zero luminance, the photo current is almost zero, excluding for a small dark current. For zero luminance means what? There is no, yes, there is no power. There is no power. Photoelectric current is almost zero, excluding from a small dark current. Okay, right. Applications of what? Photodiodes. See the applications. Photodiodes are usually as photodetectors, and photodiodes are used in cameras as a photosensors and slotted optical switch and in scintillators. Yes, scintillators, right? And photodiodes are used in consumer electronics. Consumer electronics. See, so these are the photodetectors, right? And this is also photodetector, and this is also photodetector. Okay, okay, students. Yes, right. Next, advantages and disadvantages of photodiodes. Advantages: photodiode detector are high SNIR sensitivity, nil sensitivity, and high speed. Yes, and low noise and low dark current. So low dark current. These are the advantages, and disadvantages is nothing but normal PN junction photodiodes have very high response time and it has very low sensitivity. The photodiode has very low sensitivity. This is the main disadvantage of the photodiode. Okay, students, right? Okay, so up to this photodiode topic is over. Okay, students, shall we go to the next topic? Yes, the next topic is solar cell. So we know that solar panels, no? Yes, so solar cell. Yes, what is solar cell? Solar cell, it is a device, semiconductor device, so that convert which energy? Light energy into electrical energy. Yes, that is the solar cell. Yes, the combination of solar cells is nothing but solar panel. Yes, there are different size of solar panels we used. Yes or no? Yes. Now come to the introduction. See this, solar cell is a device or is a photovoltaic device that convert the light energy into electrical energy, right? So convert light energy into electrical energy. So this device works on the principle of photoelectric effect, right? So this device works on the principle of photovoltaic effect. At the same time, if the photovoltaic devices, so that a generation of voltage of p-n junction is a semiconductor due to the absorption of light. It is called as what? Photovoltaic effect. So you know that photo electric current, no, based on that. So photovoltaic effect. So the devices based on this effect is called as photovoltaic devices. So simply we called as photovoltaic devices, right? Okay. So next, principle of photo cells, right? Principle of photo cells. Yes, principle of photovoltaic cell, it's nothing but principle of solar cell. Okay students, yes, see this, the solar cells are based on the principle of photovoltaic effect, based on photovoltaic effect, right? Okay, now the photovoltaic effect is the photo generation of charge carriers in a light absorbing material as a result of absorption of light radiation. So what is that? The solar cells are based on the principle of photovoltaic effect, right? Next, the photovoltaic effect is the photo generation of charge carriers in a light absorbing material as a result absorption of light radiation, right? See, this is simple solar cell, n type and p type. The n type is material connected to negative of the terminal, that is battery, and p type is connected to positive terminal of the battery, right? And this is the simple cell, right? So n type, p type, n type, p type. So this is the word simple solar cell. So the what is the principle of this solar cell? Photovoltaic effect. Which effect? Photovoltaic effect. Okay, okay students, right? Construction of solar cell. What is that? Construction of solar cell. See the construction. Solar cell consists of a n-type semiconductor, yes, and p-type semiconductor. N-type and p-type, and the two layers are sandwiched, and hence there is a formation of p-n junction. So sandwiched means one layer is below, above that another layer is attached, so that is sandwiched. So two layers are sandwiched, and hence there is a formation of p-n junction diode. Okay, now the surface is coated with anti-reflection coating to avoid the loss of incident light energy due to reflection. The surface of the cell is coated with anti-reflection coating, right? To avoid the loss of incident light energy due to reflection. Okay, because without light we can't produce electric current, no, that's why. Okay, now proper metal contacts are made on n-type and p-type side of the semiconductor for electrical connection. So metal contacts are made on n-type and p-type side of the semiconductor for electrical connection. Okay, right? Okay, now see that solar cell. So this is which type? This is glass, toughened glass. Okay, and this red line is anti-reflecting coating, and is the front electrical contact. So this silver color is nothing but contact. So the contact is connected, see this, connected to load, yes, and this is what? p-type silicon base. This is what? p-type silicon base, and this is the n-type. That's why see this anti-reflecting coating, n-type silicon, and this is what the red line indicate the PN junction, and this is the P type, right? And the black electrical contact, black, because black surface is a good absorber and also emitter, that's why. And the last one is polymer back sheet, polymer backsheet to protect the solar cell, to protect the solar cell. See that when the sunlight incident on the, yes, P type, sorry, cell, it will convert electrical energy, it will convert electrical energy. Okay, okay students, right? Okay, again, see this sunlight front contact when the current is generated, see like this. So one is N type semiconductor, another one is P type semiconductor. When the light incident on the surface, it will produce the photoelectric current, right? Now see this, when a solar panel exposed to sunlight, the light energies are absorbed by the semiconductor material. Due to this absorbed energy, the electrons are liberated and produce the external DC current. So it will produce the direct current, external DC current. Now the DC current is converted into 240 voltage alternative current using an inverter of different applications. So that DC current is converted into AC current with the help of the inverter, any type of inverter. Yes, okay students, okay, right. Next, types of solar cell. The types of solar cell based on, yes, crystal used, based on crystal used. The first one is monocrystalline silicon cells, and the next is polycrystalline silicon cells, and the third one is amorphous silicon cell. So these are the three types of cells, solar cells. What are the types? Monocrystalline silicon, polycrystalline silicon, and amorphous. Okay students, right? Okay, next, comparison of types of solar cell. Yes, comparison based on the efficiency. See the first one, monocrystalline silicon, their efficiency between 14% to 17%, and polycrystalline silicon efficiency between 13% to 15%, and amorphous silicon efficiency between 5% to 7%. Yes, based on the efficiency, right? The efficiency is nothing but output power to the input power, the ratio of output power to the input power. Okay students, right? Okay, now come to the advantages of solar cell. Advantages of solar cell. Okay, first one, it is clean and non-polluting. It is clean and non-polluting. It is a renewable energy. It is a renewable energy. And solar cells do not produce noise, and they are totally silent. So they are totally silent. They require very yes, little maintenance. They require very little maintenance, and they have long lifetime. They have long lifetime, and they are no fuel cost and fuel supply problems. There are no fuel cost or fuel supply problems. These are the major advantages of solar cells. Okay, okay students, right. Next we are going to see the disadvantages of solar cell. See the disadvantages. Solar cells or solar panels are very expensive. It's very expensive. Energy has not be stored in batteries. We can't store the energy. Okay, next, air pollution and weather can affect the production of electricity. Air pollution and weather can affect the production of electricity, and they need large area of land to produce more efficient power supply. So they need large area of land to produce more efficient power supply. Okay. And next, sun does not shine consistently. Less efficient and costly equipment. Less efficient and costly equipment, right? And reliability depends on location. Reliability depends on location. Okay, students, right? Okay. Next, applications of solar energy. See the applications: domestic power supply, they used in domestic power supply, and electric power generation in space with the help of solar panels, right? And drying agriculture products. Drying agriculture products. Solar pumps are used for water supply in dry areas. Okay. And water water heating purpose we use solar cells. And generating electrical power, and to providing electrical power to satellites. Okay, students, so these are the applications of what? Solar cells or solar energy. Okay. Okay, students, right? So today class is over. Okay, students, you have to go through the LED, photodiode and solar cell. Okay, students. Okay, right, see you on next video. Okay, students, thank you.